Okay, so you learned how to lay out a plot. Now we're going to learn how to measure the trees that are inside of it. First of all though, here is the flagging at the end of the trail that leads from the road up to the south end of the base transect at about 160 meters. That's the south end of the transect. And at this point, I want you to have a look at something very unusual. It is a stump that's very close to the 160 meter flags. And just have a look at this without raking too much of the moss off it, just the way it is. You should be able to see there's something very, very odd about this tree stump, and I want you to say what that is in your report. So now I'm going to move along. As you know, the transect has 5 meter flags that are marked, they're labelled, so it's starting at the north end at 0, it's labelled every 5 meters down to the 160 end. And unfortunately, I didn't realize this when I set up the transects, but other people are using blue pin flags as well, because this is a research forest and there's all kinds of research and studies going on here, and there are other studies going on in this area. So first of all, make sure that if you're following blue flags, they're our blue flags, and our blue flags have the numbers written on them. And secondly, be respectful of other people's survey markers. Let's see, well, as we go along, I'll point them out. So without really knowing, I don't know who else is working here, I'd say that somebody is working on some sort of dynamics of the understory vegetation, because I think this has been cleared. And I can't actually see one here, but there are little pin flags, some of them blue. Well, there's blue flagging up there. And then if we look at the trees, it looks to me like somebody is studying the grand fir. So this grand fir over here, look. See, this is else's grand fir. And let's have a look at some features of it. It's got flagging around it. So please don't disturb other people's flagging. And it's quite likely to have a tag with a number on. Make sure you don't interfere with that. And also, interestingly enough, this is a poison oak vine that somehow it's sort of been inside the flagging. Anyway, if you're allergic to poison oak, and I'm sure you all are, be very careful. There's not a whole lot of poison oak here, but there is some, and this one is one of them. So now I'm going to show you how to measure the trees, and this is what you're going to need. Down on the ground here we have the 15 meter fiberglass tape. Wasn't very spendy, but it's actually a very nice one. And then this object here, which is the sewing. It's a very long sewing measure, and I didn't realize they made them this long until I had to redesign this lab. But anyway, it's got inches on one side and centimeters on the other side. So if we were really seriously doing a forestry lab, we would have a diameter tape, but they're kind of spendy, and this cost about $1. So in a diameter tape, a metric diameter tape, one side would be just like this, would have millimeters, have centimeters and meters, and then the other side, instead of having inches, would have diameter units. So this, if you did circumference, this would measure the circumference. But if you measure the circumference, but then record the diameter units, it's telling you how, it's assuming that it's around what the diameter of the tree is. Since we're not doing that, we'll have to convert our measurements. So let's see, a couple of things to start with is, what's the cutoff? We don't want to take any old tree. I mean, what is a tree? It could be a big tree, a little tree, a tiny little tree, an utterly minute tree. Normally in this kind of work we have a cut-off, and we're going to have one. So normally the cut-off would be a diameter. In this case we're working for 10 centimeters diameter, but we don't have a diameter tape, so we're going to say 30 centimeters. So if your tree or the stem you're measuring is 30 centimeters or more, it's in. If it's 30 centimeters or less, don't record it. We will in fact look at those in the next week's lab, but for now we're only looking at the larger trees. So that's one in or out. Is it big enough? The species-wise, we're going to take all the species, so it doesn't matter what species it is, as long as it has a stem at the correct height, 1.3 meters, then it's in. You're going to need to record it. And another thing, another in or out criterion is the line. So you have your flagging, your pin flags that delineate your area, and you should be able to see from one to the next. So the question is, what are you going to do if the tree blocks the line? So let's have a look. Well, let's just assume, say, that this one was blocked, that the line went through this tree. There was a flag there and a flag there, and you couldn't see between them because the tree's in the way. What then, you make a judgment, okay? You look at the tree and look at where you think the line's going and see where, let's say that the plot's this way, the not plot is that way, and the line is going through the tree. So if the line is, say, here, and most of the tree is on the plot side, then that's in. If the line's over here and most of the tree is on the outside, then that's out. You're not going to use that tree. And I guess it could be right in the middle. I don't know what you do then. Either have it be in or flip a coin or do something. But anyway, that would be a very rare thing to happen. Usually most of the trees are not going to be on the line, and the ones that are on the line, it's going to be fairly easy to tell if most of them is in or out. So now, having done that, let's get started. So this is a tree. You're going to have to identify its species. So this is a grand fir tree. We have two big conifer species in here. We have the grand fir and the Douglas fir. And the Douglas fir tend to be bigger. You won't see any understory Douglas fir, and their bark is very, it's really rough. It's got huge fissures in it, like this tree over here. And we'll look at that in a minute. But anyway, the grand firs tend to be smoother. They just have, and if you can see the needles, it's quite easy because the grand firs have two-dimensional, the needles are all in one plane, they're flat, whereas the Douglas fir needles are spread all around the branchlets. But you often can't see that because, you know, you're down here and the leaves are way up there where they should be, trying to get sunshine out of the air. And, okay, so now we're going to measure. How are we going to do that? We're going to find the point of measurement. So it's going to be 1.3 meters off from the ground, approximately, but the ground is sloping. Which bit of ground? We're going to use the uphill end, and that's going to be here. So we want 1.3 meters above there while not getting too far into the poison oak. So I'm going to take my measure on the metric side, get that more or less. This isn't you know, it doesn't have to be exact, just roughly. So here we are, I've got 130 right there. So I'm going to take my measurement at this point. The reason we do that is because, you know, the bottom of the tree is often different. You know, it might flare out, or it might have things sticking out of it. So, you know, it's a standard procedure to go up that far. And now I'm going to put my measure around at about that level. And I'm going to make sure that it's level. You know, it needs to be horizontal all the way around, because, you know, if I did it somewhere else, if I had it, if it's, I don't want it like that, say. I just want to make sure that it's right, and I got it the wrong way round, so I'm going to have this end be 1. There, it says 1, right, somewhere, or 0. There's 1, there's 0. So the very beginning of the tape is 0. So I'm going to pull it tight. It's a beautifully cylindrical tree, and take a measurement. It'll give it to me in millimeters. So I'm going to do, it's going to be 98, it's between 98 and 99, and it is 98.5. So it was in the quadrat, it's a grand fir, and its diameter is 98.5 centimeters. So I'm going to write that down on this data sheet. It's going to say tree. I'm just going to put a code for the grand fir, and then the circumference is 90, what did I say it was? 98.5 centimeters, circumference. So that's all we need. We can do all the conversions later on. Okay, that was good. We've measured the tree, we avoided the poison oak, we did it for the right side of the uphill side of the tree, and we didn't disturb anybody else's markers. So let's go over and look at a different tree. Let's look at this tree. Oh my gosh, this is the Douglas fir tree. So the Douglas fir trees tend to be older and bigger, simply because of the way they regenerate. So this one's not quite so easy. First of all, we have to get round to the uphill side of it. Here I am, messy place. So, same thing, I know this is a Douglas fir because of thick, look at that, look how fissured and thick the bark is. That's typical of the Douglas fir. Whereas if you look at these branches here of this sapling, see how flattened they are? This is a grand fir sapling, and you probably have to look a long way to find a Douglas fir sapling, because they don't usually regenerate in the shade. It's one of those Douglas fir things. Anyway, I need the diameter of this tree, so let's see, this is the uphill side. I'm going to start at this end and measure 1.3 meters, more or less, give or take. That's easy enough to find that level. Where is it? Here somewhere. It's about here. Now I'm just going to reach around the tree with the measure. Here I go, and put my arm all the way around the tree, grab the measure on the other side. Oops. Not. What a problem. And if there were 2 or 3 of you, you'd be able to do this. You'd be able to put the measure round the whole tree. But since there's only one of you, what we can do is take this one. This is also in centimeters, and it's got a little thing. It's got a sort of hook in it, so we can find the right place and then push this into the bark. We may have to hammer it a bit until it stays there. See how easy this is going to be. If I've got anything to hit it with. Actually, I don't. So anyway, we want this to stick in the bark. So we might need to work at that a bit. See if we can. As I say, you might want to carry a rock or something so you can hit it. Well, let's see if that's going to work. Alright, so I've got 20, 10, and it starts right there at that exact point. So what I'm going to do is I'm going to hope that stays in place. It'll stay that place. I'm putting tension on it, so hopefully it's going to stay there. And then I'm going to go round the tree, and the measuring point, I'm going to keep this level. The measuring point will be quite a long way above the ground here. See how far down I went? Whoa! I can barely reach it. Whoa! Now I'm going to try and get back up again. Ooh! Wow! Look, this happened. So at this point, see, this is where you might easily get it not level. Anyway, I've done it, I think. So I've got to And now I can take the reading. It's got 2 meters, 40 centimeters, 40, 1, 2, 3, 1, 2, 3.9, I'm just going to call it 244 centimeters. So I've done that one all by myself. It's a little bit challenging. So 2 people, it's a lot easier to read this diameter. So this is a Douglas fir, 244.0 centimeters. So I'm just going to write that down using a code for the tree. Whatever code you want, call it DF for Doug fir, and the other one GF for grand fir. And there you go. One. There. Now, some of the smaller trees. See if we've got one handy. How about that one? Let's have a look over here. We'll just do the same thing. If there's something in the way at our height, then we'll just go a bit above or below it. And because it's small, there's not much difference in the. So we're going here. So I'm going to go down. There's a little bit swollen there. So is this in or is it out? Well, the easy way to find out, just measure it. What did you think? Do you think that was in or out? We're going 30, and that is 22. So it's out. It needs to be a bit bigger than that to be of minimum size. We're just for our study, we're calling this a sapling. But if it were in, we just do that same thing. We do the size and species, and this it's kind of hard to identify at this time of year. This is a big leaf maple because the branches sort of come out in opposite pairs. You can see, look here, that there's two together. The maples have opposite leaves. Anyway, we'll give you a guide to the things that you might find that are deciduous and that will come into the transect. So I'm going to stop there, and if I think of other things, well, I'll tell you somehow. Okay, good.